Hello students, this is part 2 video of center of mass of remainder. I strongly suggest you to watch the part 1 video. There I explain that how to find center of mass of a remainder. These are the formulas. This is example 1. Suppose this is a square lamina of total mass capital M and side A, and from this square lamina this shaded portion is removed. This part is removed, and we have to find the center of mass of the remainder. Now, as I mentioned earlier, that in center of mass problem we should define a point as origin and x-axis, y-axis and z-axis. Since this is a planar body, so we choose this as x-axis and this as y-axis, and this is the origin. It completely depends upon me that at what point I will choose my origin. Okay. Now, total mass in this case, total mass m naught is m here, and what is the center of mass of the entire square plate? This is the position of the center of mass of the square plate, which has a coordinate of very simple a by 2 comma a by 2. So x naught is a by 2 and y naught is also a by 2. Now coming to the removed part, this is the original part. Now coming to the removed part. For the removed part, what will be the mass? It is clear that this is 1/4 of the entire square plate. So m1 is m by 4. Now what about x1? x1 is the x coordinate of center of mass of the removed portion. Now for the removed portion, I can say this is the center of the removed portion. Now what will be the coordinate of this point? See, this thing is what? A by 2. So this thing is what? A by 4. The total length is A. Therefore I can say the x coordinate of the removed part is A minus A by 4, that is 3A by 4. I hope you understand. I take this distance, right? I take this distance. This is A minus A by 4. And similarly, the y coordinate is this distance, which is again A minus A by 4, that is 3A by 4. So y1 is also 3A by 4. This is for the removed part. This is for the original part. This is for the removed part. Therefore, using these formulas, I can get the position of center of mass of the remainder. So XR is m1 m naught x naught minus m1 x1 divided by m naught minus m1. Let's put the values. M naught is m, x naught is a by 2. m1 is m by 4, x1 is 3a by 4 divided by m minus m by 4, which is m will go away. So this is a by 2 minus 3a by 16 divided by 3 by 4. So 5a by 12. That is the x coordinate of the center of mass. And what about y coordinate? Y coordinate is same, m naught y naught minus m1 y1 divided by m naught minus m1, which is again same. As you see, x naught y naught same, x1 y1 same. So we don't actually have to calculate it. It's very simple. again I will get 5a by 12. Therefore the answer is 5a by 12 comma 5a by 12. I hope you understand this example. This is a very straightforward example. Okay, now I am going to the next example. Now example number 2. Example 2. In this question, let's draw the diagram. This is again a square lamina of side A, and from this lamina a circular disc is taken out, is cut out like this. You have to find the position of center of mass of the remainder. Suppose this is x-axis, this is y-axis, this is the origin. Now if you see, the center of mass of the original square plate is here, a by 2 comma a by 2. And what about the center of mass of the removed portion? The removed center of mass of the removed portion lies here, which has a coordinate of, again like the previous problem, 3a by 4 and 3a by 4. Now what about the mass? For the original portion, m naught is m, x1 is a, x naught is a by 2 and y naught is a by 2. This is for the original part before removing this disk. Now for the removed part, I can say m1, I don't know, x1 is 3a by 4, y1 is again 3a by 4. Now what is the proper way to find this m1? You can use the unitary method. That's the most simplest way. Now what is the area of the entire disc? This is a square, a into a. Now mass of this area is nothing but m, that is the mass of the square plate. Therefore mass of unit area is what? M by a square. You can call this quantity as areal mass density, that is mass per unit area. Now what is the area of this circular plate? Now the radius of the circular plate is simple, a by 4. Radius of the circular plate is simple, a by 4, right or wrong? Therefore area of the circular plate is pi into a square by 16. Therefore we can say that the area of the square plate is pi m by 16. Therefore I can say this m1 is nothing but pi m by 16. I hope you understand. Pi m by 16. Now these are the quantities which are important. Okay, now it's time to find xr and yr. Proceeding to the next slide. Xr, simple, m naught is m, x naught is a by 2 minus m1 is pi m by 16, x1 is 3a by 4 divided by m minus pi m by 16, and yr is also same as the xr. I hope you understand. I will not finish the calculation completely because I just want you to understand the process of finding center of mass of the remainder. I hope you understand this example. Okay, going to the next example. This is example number 3. Example 3. Here we also have a square lamina, but in this case a triangular portion like this is removed from it. Suppose the side of the square plate is A and the total mass is M, and I take origin as this point as origin. This is x-axis, this is y-axis. Now for the total portion or total plate, square plate, I can say that m naught is m, x naught, this is the position of the center of mass, is a by 2, y naught is a by 2, same as before. Now for the removed part, this is interesting. For the removed part, now see students, this triangle is not an equilateral triangle. This is basically an isosceles triangle. This side is a, this side is a by root 2, and this side is a by root 2. This is an isosceles triangle. Now what will be the position of center of mass of this triangle? Now it is clear that the position of center of mass will certainly be situated here, and the y coordinate of that point is obviously a by 2. But what about the x coordinate? Now if I draw the triangle here, this is a, this is a by 2. Therefore I can say that the center of mass, this point, will divide this height in a ratio of 2:1. Therefore the position of center of mass will be 1/3 of a by 2, that is a by 6 above this point, right or wrong? A by 6. So I can say, let's erase it, I can say for sure that this thing is a by 6, that is 1/3 of a by 2. Therefore for the removed part I can say the mass is simple, m by 4, because for a square plate the 4 triangles are of equal area, so m by 4. x1 is, see, this thing is a, this thing is a by 6, so x coordinate is a minus a by 6, that is 5a by 6, and y1 is simple a by 2. Therefore I can say that xr is m into a by 2 using the formula minus m by 4 into 5a by 6 divided by m minus m by 4, which is very simple calculation. A by 2 minus 5a by 24 divided by 3 by 4, so 24 LCM, 7a by 3 by 4, that is 7a divided by 32, sorry, not 32, 7a divided by 18. Now that's the x coordinate of the remainder, 7a by 18. What about y coordinate? Y coordinate will be very simple, since the y naught is also a by 2, y1 is also a by 2, so I hope you can guess it. yr would be total mass into y coordinate minus m by 4 into y coordinate divided by m minus m by 4, so it is obviously a by 2. Now I hope you understand the procedure. Okay, now coming to the example number 4. Here first, this is the first example where I will remove two portions from a disk. So let's draw it first. Suppose this is a uniform disk and of total mass say m and radius say r, and from this disk two disks are removed like this. See, for this disk the radius is r, so for this disk the radius will be r by 4. I hope you understand. And for this disk the radius is r by 2. Two portions are removed. Okay, this is the first portion and this is the second portion. You have to find the position of center of mass of the remainder. Suppose this is the x-axis and this is the y-axis, so this is the origin. Therefore I can say for the whole disk m naught initial mass m, x naught 0, y naught 0. Okay, now two portions are removed. For the black portion, that is this, for the black portion, this one, I can say that what will be the mass. Yes, I hope you can guess it. The mass of this portion is m by 16. Why? Because the entire disk has area of what? Pi r square. Mass of pi r square is m, so mass of unit area is what? M by pi r square. Now you can see the area of the black disk is what? Pi r square by 16, so it is nothing but m by 16. I hope you understand. m1 is m by 16. What about x1? x1 is this thing, that is r minus r by 4, that is 3r by 4. And what is y1? y1 is obviously 0. Now for the second removed portion, that is the blue portion, this disk. For the second disk I can say m2. m2 is nothing but m by 4 by using the same method. Here the area of the blue disk is, this disk is what? Pi r square by 4. So area of pi r square is m, so area of pi r square by 4 will be m by 4 obviously. x2. Now see x2 is minus r by 2. Be very careful. I take this direction as positive x, so this direction is negative x. Here the center is situated here, so minus r by 2. y2 is 0, so we don't have to calculate yr. I can calculate only xr. xr is what? m naught x naught minus m1 x1 minus m2 x2 divided by m naught minus m1 minus m2. Putting the values, see, m naught is m, x naught is 0, minus m1 is m by 16, x1 is 3r by 4, minus m2 is m by 4, x2 is minus r by 2. So don't forget the negative sign, divided by m minus m by 16 minus m by 4. Now this is the procedure. Therefore I can say this is minus 3mr by 64 plus mr by 8 divided by, if m is common, 16 is LCM, 16 minus 1 minus 4, that is 16 minus 5, that is 11. So you will get the answer eventually. yr is 0. Now that's the procedure. I hope you understand my objective. And for homework I can give you a homework. For homework you can do this problem. Suppose this is not a disk, but this is a uniform solid sphere of mass say m and radius say r, and from this uniform solid sphere another sphere is cut out. This sphere is cut out. It has a radius of what? It has a radius of r by 2, right? Now you have to find the center of mass of the remainder.